Hi everyone. In this video, we are going to discuss about the third theorem, which is the midpoint theorem. And the theorem says that line segment joining the midpoints of any two sides of a triangle will be parallel to and half of the third side. Now let's suppose we have a triangle ABC as you can see in the diagram. Now I'm going to join the midpoints of side AB and AC by a line segment. And let's suppose that the line segment is DE. So the midpoint of AB is D and midpoint of AC is E. That means AD will be equal to DB and similarly AE will be equal to EC. And for this theorem here we have to prove that DE is parallel to BC and also DE is half of BC. Those are the two things that we have to prove for this theorem, right? Now to prove the theorem, we have to do a little more additional construction. So first thing I'm going to do is I'm going to draw a line segment which will be parallel to AB, and I'm going to draw it from the point C, from the vertex C, and let's suppose that line segment is CF, which is parallel to AB, and then I'm going to extend DE to meet this new line CF at a point G, and our construction is complete now. So CF is parallel to AB and D and E, they are the midpoints of AB and AC respectively. Right? Now let's look at the triangles ADE and ECG. So we're going to compare these two triangles and try to find some similarity. Between these two triangles, we can clearly see that AE is equal to EC because E is the midpoint of AC. So we can say that AE is equal to EC, and let me also make a note of that right here. And if you think about the angle AED and angle CEG, they are vertical angles, so they will be equal in size. So angle AED and angle CEG, they will be equal. So I'm going to use an equal sign right here. And also if we look at the angles DAE and ECG, those two angles are also going to be equal because they are the alternate angles between the two parallel lines AB and CF, assuming AC is the transversal. So if we assume that AC line segment is the transversal, then angle DAE and angle ECG, they will be alternate angles. Therefore, they will also be equal, right? Now think about it. We have this angle A is equal to this other angle which is angle ECG. They are equal angles. And then this angle right here, angle AED, is equal to the angle CEG right here. And then the common side which are AE and EC, they are also equal. So now you can clearly see that we can use the ASA criteria of congruence, and we can say that according to the ASA criteria, these two triangles will be congruent triangle. And I have noted that right here, using ASA criteria of congruence, triangle ADE is congruent to the triangle ECG. Now that we have been able to prove that those two triangles are congruent triangles, we are going to use the CPCT property which says that the corresponding parts of congruent triangles are equal. So using that property, what we can find out? Well, we can clearly see that CG will be equal to AD because they will be considered the corresponding parts of these two congruent triangles. So we can say that CG is equal to AD, and also we know that AD is equal to DB because D is the midpoint of AB. So we can say this AD is also equal to DB. And now if you look at the quadrilateral DBCG, it looks like a parallelogram, right? And actually it is a parallelogram. Why? Because it has two parallel sides which are DB and CG. They are parallel to each other and also they are equal to each other, meaning their lengths are equal. And we know that for a quadrilateral, if we have a pair of opposite sides which are parallel and equal in length, that quadrilateral is nothing but a parallelogram. So in this case, the quadrilateral DBCG, that is actually a parallelogram. So then DG will be parallel to BC, and in other words we can say that DE will be parallel to BC because DG is nothing but an extension of DE. So if DG is parallel to BC, because this quadrilateral has been proved to be a parallelogram, then we can say that DE will be parallel to BC. And that was one of the items that we needed to prove, that DE will be parallel to BC, and we have proved that already. And also we have to prove that DE will be half of BC. Now if you think about DE and EG, they are also two corresponding parts of the two congruent triangles, DE and EG. They will be corresponding parts of those two triangles. So DE will be half of DG, and because it is a parallelogram, DG will be equal to BC. So we can say this is nothing but half of BC, and you can clearly see that we have been also able to prove that DE is equal to half of BC, and that was the second item that we needed to prove. I hope everything made sense. Thank you for watching. See you in the next video.